Hey y'all. Today I'm going to be showing you how to make this outline shader effect that looks like this in Unity using HLSL shader code. So without further ado, let's jump right in. So the first thing you're going to need to do is you're going to need to fire up a new project in the universal render pipeline for Unity. I'm going to be using a 3D project, but this sort of effect also technically should work for 2D, but the implementation will be different. Um, So, first things first, we're going to need an object to apply this effect to. I usually opt for a cylinder, or a capsule rather, just because it has some rounded edges and it has some flatter edges that are easier to see, and it's curved, so that lets you sort of know that your normals are facing the right way, which we'll get into later. But just create a capsule. I've aligned the camera in this instance to look at the capsule, so we can just go right into the game view and see exactly what it will look like. And I'm going to back out of this assets folder here. So the first thing we're going to need for a shader to be applied to this capsule is we're going to need a material to run the shader through. So we can just go ahead and create a new material, and we'll call this Toon Outline. Um, and this shader will be applied to this capsule. So let's go ahead and select the capsule here, and we can drag it on here, and we notice now we have our new material right here. So this material right now is using the Universal Render Pipeline lit shader. Our shader is going to be unlit, so it's not going to respond to lighting. You can extrapolate this to lit shading if you want, but that's a task for another time. So next we're going to need to change this shader to something custom that we can work with. So let's go ahead and create a new shader here, and we're just going to create an unlit shader. We can call this Toon Shader. And so this file is where we're going to actually be writing shader code. And if we select it in here, if we go to Toon Shader, you'll notice our capsule disappears. This is because we need to go to render queue and go to transparent here, and then our capsule will reappear. So now that we have this capsule, we're going to need to delve into this actual file over here for a little bit. So first things first, this is in a language called ShaderLab. That Unity uses for its shaders. We're only going to be using a small portion of this actual ShaderLab structure. But yeah, so if you want to learn more about how these are structured, you can go look at the Unity ShaderLab resources, specifically the HLSL resources, which is the language we'll be using today. So first things first, we're going to need to clean this up because we're not going to need a lot of this stuff, and we're actually going to be writing it in a different language than this CG program thing here tells us we should be writing in. So first things first, we're going to go up here to the properties and just get rid of all of the properties for now. Properties is where you can specify like user variables. So if the user wants like on the material to be able to modify like the color or the size of the outline and whatnot, that's where you can do that. We're not going to be covering that for this tutorial, but more than feel free to go back in there and expose some of those internal variables to the user. So the next part, I'm just going to format this a little bit. The next part is this sub shader section, which I'm going to indent right there. So this sub shader section has two important things. First of all, I mean, we don't need that LOD. The first thing is the tags. So this tags our shader with certain attributes that Unity uses to sort out its rendering. In this case, our render type is opaque, which means light hits this and then it stops there. It's not going to try to pass through it. Next, we're going to need to look at this pass field. And this pass is actually where our shader code is going to go. But for now, we can just about delete this whole section here. I'm going to add back the braces. But yeah, you can go ahead and clear all of that out. And let me disable my my little auto assist thing. All right. So now we have our basic shader, bare bones structure. So again, tags tells Unity how to render stuff. Pass the actual shader code. So in our tags, we're going to need to add a tag here to tell Unity to render this with the universal pipeline. So we're going to go and say render pipeline, and we're going to set that equal to universal pipeline. I'm going to space that out. Notice that there is there's no comma here. It's just an empty space. All right, and we can move swiftly onward to our pass. So the first thing we need to do is we need to tell Unity what language we're going to be running this shader in. And so we're going to surround our shader code with two signifiers that will tell Unity this. So we're going to be writing in HLSL, which stands for Higher Level Shader Language. It's a language created by Microsoft for GPU coding, based loosely off of GLSL. So if you've worked with that before, this might ring some bells. So first things first, we're going to need to type out HLSL program in all caps. And this will start our HLSL program, and we're going to need to end it later with end end HLSL. And between these two things is where we're going to get our actual shader code running. So there's two parts of our shader that will actually run on the GPU. The first is our vertex shader, which will run for every vertex on the mesh that we are applying this shader to. So for the cylinder, it'll run for every vertex on that cylinder, on every face. And the second part is a fragment shader, which will, in essence, this is a pretty gross oversimplification. You can get really nitty gritty with this, but it'll basically run for every pixel on our object. And so you can sort of think about it like that and conceptualize it that way, and it'll make a little more sense. So first thing we need to do is tell Unity what our functions are going to be called that are going to be dealing with the vertices and dealing with the fragments. So to do that, we can go ahead and type pragma vertex, and that will tell it that we're going to specify the vertex function here. We'll just call it vert. And next, we're going to specify the fragment shader. So we're just going to copy that down. You can change this to fragment. And the name of this function for our purposes is going to just be frag. So vert and frag are going to be our functions that deal with our vertices and our fragments, respectively. Next, we're going to need to include some stuff from Unity that helps us write shaders. This comes from the Universal Render Pipeline library. And if you actually look in, little sneak peek there. If you actually look in Unity, in your packages, in your project browser, in Universal RP and Shader library, this is where we're going to be importing from, and you can actually see this core file right here. This is what we're going to be including. So to include that, you can copy this path down here, but I'm just going to have to type it out, I think, because I don't know if it's going to let me copy that. So if you go ahead and type include, and then in quotes, you're going to type packages /com.unity.render-pipelines. This is going to be long, .universal. So we're in the universal pipeline. And then that folder we were at before called shader library /core.hlsl. And this will include that file in there. And actually the core file, if you delve into it, is just a bunch of preprocessor stuff and some comments that actually load more files. So you can see there's a hash include for a bunch of different files over here. But we don't need to worry about that today. So after we have our functions notified to Unity, Unity knows which functions they're going to be, and we have included all these resources, we're going to need to define some data structures to pass data in from Unity into our vertex shader, and then from our vertex shader to our fragment shader. So our first struct is just going to be to pass information into the vertex shader. So I'm just going to call this app. And in this structure, I am going to, well, first we need access to the position of the vertex, and then we need access to the normal of the vertex. And so we're going to do that by defining two vectors, one of 4 floats and one of 3 half precision floats. So the way you define a vector in HLSL is by typing the type of the variable and then the number of components. So our first vector is going to be a float 4, so a 4-component float vector called position OS, which stands for object space. So this is going to be the vertex coordinates relative to the origin point of the object in the scene. So when we're defining variables for these structs, we're going to need to tell Unity what we're intending to do with them so it can funnel in the right data. And so in this case, we're just going to tell it that we want the position. And that's going to give us the position of our vertex. Next, we're going to need the normal of our vertex. So that's going to be a half 3, which will be a 3-component vector, and that's going to be our normal vector. And we can just tell Unity that we want this to be our normal. And so now in this structure, we have our position and we have our normal for our vertex, and this is going to get passed into our vert function, which is defined that we're going to be using vert for our vertices up here. So this is going to get passed into that function, and we're going to do stuff with that, and then we're going to pass in another struct into our frag function that we construct in our vertex shader. So we can call that struct. V2F is a common name, so vertex to fragment. And in here, let's start defining some variables we're going to need for this effect. So the first thing we're going to need is another float 4, but this time it's going to be position HCS. That's what it stands for. So HCS stands for homogeneous clip space, which is a fancy way of saying -1 on both the X and the Y on your screen. So basically just screen space coordinates. These are our actual coordinates for where the pixels will end up on the screen. And so that's going to be our SV underscore position. Almost started typing out underscore there. So SV position just tells Unity, hey, put the fragment coordinates into this. We're actually going to end up setting these in our vertex shader ourselves, but this designator is required. Next, we're going to need another normal vector, so we can just copy this from up here. We are going to need to change this designator over here, though, to text chord 0. And text chord just basically tells Unity this is a basically a high precision number. And we're going to need a few more half 3s, so I'm just going to copy that a few times and go ahead and increment these. So we're going to need first, we're going to need a world pos. And so this is going to be the position of our fragment in the world. So if you think about it in world space, like the capsule is located around 0, 0, 0. The actual pixel that's getting shaded onto the screen, where is that in the world? So that's this variable right here. And next we're going to need our view direction. So view dir. And this is going to be the direction from basically the camera to the fragment that we're trying to shade in the world position. And so now that we have both of these structures, we can start writing our functions. So the first, if you remember, is going to be our vertex function, and that's going to return that v2f struct that will pass to the fragment shader. So first things first, we're going to type v2f for a return type, and then our function is going to be called vert. And this is going to take in our app struct from before. We'll just call that in. And so we'll leave that method body bare for now. Our second function is going to be called frag, and this is going to return a half 4. So if you remember from before, that's a 4-component vector of half precision. And that's going to be for our color. So the 4 components are for red, green, blue, and alpha, respectively. And so this function is going to be called frag. And the fragment shader is going to accept one of those v2f structs, and we can just call that in again. And this time we're going to need to specify that this is the sv underscore target. So this is what we're like our target is for the shader. Don't worry too much about those specifiers. They are just a necessary sort of bit of syntax to include in our fragment shader. So now that we have our 2 methods outlined, let's start building out this vertex shader. So our vertex shader is going to need to return one of those v2f structs. So let's just create one, and we can call this out. And then at the end, we're going to return out. And then in the middle here, we need to fill in the data for what we're going to be returning. So first, let's fill in that position HCS. And this is going to be equal to the transformed coordinate of this vertex into that homogeneous clip space I was talking about earlier. And Unity has a helper function for that. It's called transform object to hclip. And in here we can just pass in our which is our stuff that we're sending into the vertex shader, dot position os, which is, remember, our position in object space. And then we can go ahead and get its x, y, and z components, because it takes in a 3-component vector. And this syntax here is a little bit of shader syntax called swizzling, where it just takes those components and only those components from the vector and constructs a new vector of the correct number of components. So because our position OS is a float 4, and this function transform object to hclip takes in a float 3, we need to swizzle here to get our coordinates out. If you don't believe me, look it up. That is a real term. All right. Next, we're going to need to pass into our normal field here. And our normals are going to be helped by Unity again with another function. So we can just type out transform object to world normal. Long function names. But yeah, and we can just pass in our normal here. And that will be the correct normal. Next, we're going to need to set up our world position. So we're going to do out.worldPos equals, and here we're going to need to do a matrix multiplication actually to get from the object coordinate system into the world coordinate system, from the vertex object coordinate into the world. And so basically, Unity has a built-in matrix to do this. If you aren't familiar with matrix multiplication and multi-dimensional transformations and whatnot, don't sweat. You can just copy what I type out here and go investigate it later. I do recommend investigating it though if you're interested in this kind of stuff, because it is used quite frequently. So first we're going to need to do a matrix multiplication, which is the mul function. And we're going to be filling in this mul function with first the matrix that we need. So that's going to be unity underscore object to world. And that'll transform from object space into world space. And then we'll just need to type in dot position os for our object space position. And this is from that abstract from before, and that will transform it into the world position. And finally, we need to just get the view direction. So out.viewDir, and our view direction is going to be a normalized vector. So we're going to normalize here, and we're going to use another helper function to get the vector from the view towards that world space coordinate that Unity provides us. It's called get world space view dir. Very verbose function names here. and where you could just pass it in that world pos. Awesome. So that just about does it for our vertex shader. It's going to set up a bunch of data for a fragment shader and then send it off to our fragment shader. And now we can actually work on the effect. So the first thing that we're going to do is I'm going to define a half-3 called final color. And this is going to be the color that ends up getting passed to Unity for the color of each of the pixels that it gets run over. So for now, we can just say half-3, and we'll do, 1.0, 0.0, 0.0, which will be full red, no green, and no blue. And then at the end of our function, we can just say return, and we're going to return a half-4 of our final color with 1 for our alpha. And now that we have this set up, we can actually go back to Unity, and if we tell it to refresh here, you can see our object is red. Congratulations, us. You have successfully written a shader. Now, this effect is not super interesting, but it is actually running that shader on your GPU and coloring the object according to the stuff you wrote in that fragment shader. So let's go back there real quick and let's keep exploring. So one thing that can be useful to us is the way we're going to be doing this effect is we're going to be working with the surface normals of that object. So if we want to visualize those, we can actually color the object with those surface normals. And so our surface normals are going to be another half-3, and this is going to be the color. So if we do fill color, and we can set that equal to in dot normal, but normals range from -1 to 1, and unfortunately negative colors are not visualizable. So we can have that range by multiplying by 0.5 to clamp it to -0.5 to 0.5, and then we can move that up from 0 to 1, and that will be in the correct color space. So if I just add 0.5 there, and that will be in our correct color space. So for now, we can actually just set our final color equal to our fill color. And if we pop back over to Unity and refresh, you can see there are our normals. So more red means further on the X the normal is pointing. More green means further on the Y the normal is pointing. And further on the Z means or further on the blue axis means the further Z it's pointing. So next we're going to need to actually do the outline. And so if we look at our cylinder here, what we want to do is we want to isolate the space on this edge here. And you can kind of see in the coloring that this center space is pretty homogeneously colored, and then the edge gets pretty extreme. But something that all of these edges have in common is that they are facing, the normals are facing perpendicular to our camera's view direction. And so one really good way to detect if something is facing perpendicular to another vector is by using the dot product. And so we're going to take in our shader, we're going to take the dot product. So let's make a new variable to store that product. And we're going to take the dot product of our in normal vector, which is our normal vector, and the in view direction. And this will return 0 when it is perfectly perpendicular, and 1 when they're perfectly parallel. Perfectly parallel. Say that 5 times fast. All right. Next, we're going to need to sort of clamp this from 0 to 1, but we could already sort of visualize this if we go ahead and multiply our fill color by our dot product. Then if we go ahead and visualize this here, you can see we've actually darkened the edges of this shape already. However, this is sort of a continuous gradient and is not the effect we're looking for. So to get that effect, all we really have to do is just say below a certain value, make it completely black, and above a certain value, make it completely whatever the fill color is. So let's go ahead and go back into our shader. And to do that, we can just set the dot product equal to a function called step. Now what step is going to do is it's going to take two arguments, the first of which is going to be a threshold, and the second of which is going to be a value to clamp from 0 to 1. So if the value is below that threshold, it'll be 0, and if it's above that threshold, it'll be 1. So what we can do for that is if we just want to say, okay, 0.5 is our threshold. If it's sort of up until about a 45 degree angle for the normal, it should just be black, and then as it faces more towards the camera, it can become the actual color. So, and we want to be clamping our dot product here. And so, if we fill that in real quick and we refresh, you can see we have our finished shader. And this works in the scene view. If you fly around it, you can see that the different sides of the object are being correctly shaded. So yeah, hope you enjoyed this tutorial. If you want to expand on this, you can of course go back to here and say maybe we want the fill color to be that red color from before, and of course that will work perfectly fine. So yeah, I encourage you to go out and experiment with different types of shaders and different types of shader code. Hope this was interesting, and yeah, hope you find some use in this. Yeah, thank you so much for listening.